Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of simple and compound probabilities. This is standard 7.6i in the great state of Texas, and we are using item number 53 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So, on Roberto's shelf, we've got some different books: mystery, science, history, and adventure. So he's going to randomly choose one book to read. So what is the probability that he will choose an adventure book? So choosing simply one book to read is what we call a simple event. So it's simple because you just make one choice. So we're going to look at that for this particular problem. If we were needing a compound event, it would be something like this. He randomly chooses one book to read, he puts it back, and then he chooses another book. That would be a compound event. Or the second event doesn't even have to be related to the books. Maybe he chooses a book, and then he rolls a die and he's trying to land on the number 5. What are the chances of him getting a mystery book and rolling a die and landing on the number 5? That's a compound event because it takes more than one simple event and just change it together. So let's take a look at our books. So I'm just going to draw some letters here. So I've got some 6 mystery. I've got 5 science. 2, 3, 4, 5. Notice how the numbers get smaller here. 4 history. And then 3 adventure. Alright, so those are all my books. Let's pretend those are all on the shelf, and I want to simply randomly choose one. So what is the probability that he is going to choose an adventure book? So let's represent this probability with a fraction. And so our numerator, in this case, is going to be the number of adventure books that there are, how many adventure books that we have. And then our denominator is going to be the total number of books, because really that's what we're looking at. If he closes his eyes and picks a book at random, how many adventure books do we have? And so you see here, we've got 3 adventure books. They're all kind of shoved down here at the back. How many total books do we have? Well, we haven't added them up, but we can either count them all the way across, or we can just do a little bit of addition. So 6 and 4 make 10. 5 and 3 make 8. Here we go, so 18. So there's our fraction. We've got 3 out of 18. Obviously, that's not one of our choices, but look, I see a 3 here. I see an 18 here. Both of those are extremely tempting, but what we need to do is we need to make an equivalent fraction. We need to reduce or to simplify. And I wanted to show it to you in this manner because I want to show you visually how we could reduce this. So the way it's viewed right now is that each of these letters here, from the M's all the way down to the A's, represent a different book. But what if we were to take this into chunks? So what if we were to take this into chunks of 3? I want you to watch this. So I've got 2 chunks of 3, 3, 4, 5, 6. Okay, so you notice obviously I'm not adding or subtracting any of the books, but what I'm doing is I'm putting them into chunks of 3, and guess how many chunks I have? 1, 2, 3, 4, 5, 6. And then how many chunks of 3 are my adventures? Well, thankfully, they all added up into just one chunk of 3. Now, that's visually how you could make an equivalent fraction. Some of you probably just use the algorithm here. You divide it by 3 over 3. But either way, your answer is not going to be A, B, or C. Those are red herrings that we're not going to chase. The answer here is D, 1/6.